Hello, class. Today we're going to be covering combustion engines in 5 minutes because that is the allotted free time for this program. So how do cars get us places using gas? This is going to be through the internal combustion engines. This modern technology has allowed people across the world to mobilize and has assisted with the industrialization of many nations. The science behind this is deemed the four-stroke engine cycle has 4 steps: intake, compression, expansion, and exhaust. The first step of intake is where a fuel and a oxygen mixture is is brought into the cylinders via the intake valve, one of these two valves on each cylinder. The camshaft and rocker arms may help manage multiple intake valves as well as exhaust valves that we'll talk about later. In order to increase power at this level, you can actually increase the amount of fuel you put in during the step in that mixture, and that will increase the energy density. In order to have higher efficiency, you can actually invest in cylinder deactivation technology, which, depending on the actual needs of the engine at any given point in time, will turn cylinders on or off depending on the need. Turbocharging is where it will actually allow for more oxygen to be brought in at this step and also assist in combustion. Nitrogen or nitrous oxide is actually one of the undesired byproducts of intaking ozone for this reaction. That is what I say. The next step is compression. Once the fuel and air mix has filled the chamber, the piston actually starts to compress this mixture. The larger the cylinder, the more power you can get out of the reaction because there's a larger amount of gas that's in the end being compressed. Maximizing the amount of compression you have prior to ignition will actually increase your efficiency. So once this gas is compressed, the spark plug actually activates and ignites the mixture, and then we have expansion. In this step, the ignition causes an explosion within this internal chamber, and this pressure pushes the piston back downwards and turns the crankshaft. This is where the chemical energy is put into is changed into kinetic energy and actually propels the vehicle forward. Depending on the gear, you can actually affect how much power you're getting out of it for the same volume of gas or fuel being used, which affects the rate at which it turns. Step 4 is going to be exhaust. So once this explosion has happened, there are leftover fumes. As you can see in this little picture, you have your fuel, your oxygen. So those are going to be brought in. You're going to have combustion. And you're going to end up with carbon dioxide and some water in the form of gas. There's also, depending on how imperfect the combustion is, you'll have hydrocarbons, I believe is the term, and then the nitrous oxide we mentioned earlier, and then the cycle starts over from there. This is another review really quick of the full cycle. You'll have the intake where the fuel is put into the engine or the cylinders, the compression where it's compressed and put into denseness. Expansion, once it explodes, this is where the kinetic energy is formed, and then the exhaust is the leftover fumes. Other opportunities to increase power and or efficiency in the process include having an engine that is best suited for the vehicle's needs. You don't need an oversized engine for a small vehicle, so that is a method. Improved operation can have a list of implications. This kind of goes more with driving habits. Road load reduction is going to involve reducing the weight and the friction and the additional things that affect efficiency. Integrated start-stop will reduce idle time and wasting fuel, and load decoupling and regenerative braking are hybrid technologies that help increase efficiency.